In this example, we are looking at a two-way table. This data comes from a Pew Research poll of 1,306 Americans. They asked these Americans, from what you've read and heard, is there solid evidence that the average temperature on Earth has been getting warmer over the past few decades or not? So our table here shows the distribution of responses by party and ideology. And instead of just the counts of the folks that answered, we have the relative frequencies. So they took each count and divided it by the total 1,306 Americans who took the poll. So what we see here are relative frequencies or decimals of the part out of the total. If you would rather think about these as percents, you could just shift the decimal two places. So for example, we see 0.11 of the folks surveyed here in this first entry are conservative Republicans who believe that the earth is warming. Our response is here in the columns, and our party and ideology are in the rows. That 0.11 you could translate and think about that as 11%. So we see in the bottom right part of the table, the total is 1.0, or what we think of as 100%, because if everyone is surveyed, the total should be 100%. So that 100% corresponds to the 1,306 Americans. If you're doing a survey, you can always convert your table to a relative frequency table. You just take each entry and divide it by the total number surveyed. And there's advantages to doing this because it's a little bit easier to think about things as a part out of the total or a percent when we're doing our comparisons. Question A asks us, are believing that the earth is warming and being a liberal Democrat mutually exclusive? So remember, mutually exclusive would be if there was no overlap, or the other term we use is disjoint. So if we look here at the categories being a liberal Democrat and believing the earth is warming, we see down here in the very bottom of the first column that there are actually 0.18 of those surveyed who are liberal Democrats who believe the earth is warming. So my answer here explains that no, these categories are not mutually exclusive and there is overlap. 0.18 or 18% of those polled are liberal Democrats who believe the earth is warming. So for something to be mutually exclusive in a table like this, we would need a zero entry, meaning no one was in both of those categories, liberal Democrat and believing that the earth is warming. If you take a look at this table, the smallest values we have are 0.01 or 1%, so there's no mutually exclusive categories in this table. Question B asks us to calculate what is the probability that a randomly chosen respondent believes the earth is warming or is a liberal Democrat. So since this is an or question, that means the people we want to count up can belong to the earth is warming category, or they can be a liberal Democrat. They don't necessarily have to be both. So you can see my highlighting on here. I highlighted in yellow the earth is warming column. The total for all the entries in that column is 0.60 or 60%. And then you can see in yellow I highlighted the liberal Democrat row. The total for that row is 0.20 or 20%. I want to add up these probabilities, but I want to make sure I'm not double counting any group. So if you look at my highlighting, you can see it crosses over 0.18 liberal Democrats who believe the earth is warming, and that gets double counted. So to do my or calculation, I need to add up everyone who believes the earth is warming, everyone who identifies as a liberal Democrat, and then subtract the overlap. So my calculation here is 0.60 plus 0.20, and then subtract 0.18. So I have 0.62 or 62%. You could have also just counted up the areas that don't overlap. So you could have said, hey, I'm going to count the earth is warming column with 0.60 and then add in the 0.01s from the liberal Democrat row under not warming and don't know or refuse to answer. And so you could have said 0.60 plus 0.01 plus another 0.01 also totals 0.62. As long as you're not double counting the overlap, you can add this up in any way you like. Question C asks us, what is the probability that a randomly chosen respondent believes the earth is warming given he or she is a liberal Democrat? I've underlined the given he or she is a liberal Democrat part here. That's our restriction or condition. So we are not going to be looking out of the total of everyone surveyed. We are just looking at the liberal Democrats. So if we come up to our table here, that bottom row I've highlighted is the liberal Democrats, and their total is 0.20. So we are going to look not out of 100% or 1.0, but out of 0.20 or 20% of those surveyed. When we do a conditional probability like this, and we're analyzing a table, we are restricting our calculations to either a given row of the table or a given column in the table. In this case, because our given condition is that the folks are Liberal Democrats, we are restricted to this bottom row here. So our calculation here is going to be out of the Liberal Democrats, what part believe the Earth is warming? So that is 0.18. And then we see if we do 0.18 out of 0.20 and we want to convert that into a decimal we can interpret, that's 0.9, or we can think about it as 90%. So we can say of the Liberal Democrats, 90% believe the Earth is warming. Part D asks us to do a similar calculation, but now our condition is that he or she is a conservative Republican. So notice in our notation, after Earth is warming, in this probability, after the line there, we've put conservative Republican, or CONSREP for short. So that tells us that we are restricting this calculation to conservative Republicans. This is the shorthand notation for conditional probability. You can draw a line here and then put after the line which group you're restricting to. You could also use the words given that they're conservative Republican when you write up your probability. So we see the conservative Republicans are up here in the top row of the party and ideology. And so I tried to highlight those in orange. It's a little tough to see, but the total of that top row is 0.33. So we want to know what part of these folks are believing that the Earth is warming, and so that is 0.11. So as a fraction, we can say 0.11 over 0.33. That's like 11 over 33, or 1/3. So when we divide, we see as a decimal, it's 0.3333, or 33.33%. It's your choice when you report these. You can leave them in decimal form. Percent's okay too if you prefer to think about probabilities that way. Question E asks us to think about another conditional probability, but the difference here is that now we are restricting to people who do not believe the Earth is warming. So the question here asks us, what is the probability that a randomly chosen respondent is a moderate/liberal Republican, given that he or she does not believe the Earth is warming? So notice in our notation here, in the probability in parentheses, our line in the second part is not warming. You can always think about the restriction as coming second in the probability notation, and it corresponds with the denominator. So notice our denominator here is 0.34 because that's the total of the not warming column that I've circled up here in purple. So out of those who do not believe the Earth is warming, we are looking to figure out what part are conservative Republicans. Oh, I'm sorry, moderate or liberal Republicans. So those are 0.06, the second row here in this not warming column. So our calculation is 0.06 over 0.34. Again, it's hard to think about dividing the decimals as a part or a percent, so we divide right away and put it into our decimal or percent form. So as a decimal, that's 0.1765, or as a percent, 17.65%. So what that's saying is out of those who don't believe the Earth is warming, about 17 to 18% are moderate or liberal Republicans. So this is not out of the whole survey. We're just restricting it to those who do not believe the Earth is warming. And so we call this a conditional probability because there's a restriction here.